my work is derived from electronics. And previous work is how other researchers made their work based on adder circuits, which I am working on, which I worked on. And objective is based upon just the title itself, like analysis of adders in deep submicron, and research method. Research method is how I did my work, how the procedure goes on, my research. And background work is basically upon finding the interconnect parameters regarding the transistors and the scaling methods. And CMOS technologies, quite like I took in 4 CMOS technologies, kind of static CMOS, pass transistor logic, and the proposed circuit from the previous literatures. And results what I obtained, and conclusion is what I concluded based on my work and compared with the previous work. So introductions, modern day electronics. As we can see, electronics are everywhere. We have high definition televisions, we have global positioning system in our cars, we have music systems, everything, whatnot. Electronics are everywhere today, and we are getting along with them, and they are getting advanced day by day, and they are getting portable by time to time. And these electronics have as an integrated chip in them, which is basically a digital processing chip. The fundament, all these electronic devices have one thing in common, that is digital signal processor in them, which has an adder circuit, the fundamental circuit in each digital signal processing chip. So, digital signal, as I already told you, adder circuit is a fundamental circuit in the digital signal processing chip. Okay, optimization of this adder chip, this adder circuit is the main concern right now, and VLSI designers are working on this for a few decades. As I specified, VLSI designers, introduction of VLSI was like Gordon Moore in 1965. He predicted that for every 24 months the transistors on a chip will be double. So it went well for 4 decades. So scaling was pretty good. That's how we are getting the portable electronics nowadays, and small, like we can have handheld computers and everything. So scaling is pretty much good. And as we are scaling, there will be some effects, which are second order effects, which will be degrading the performance as we scale down. So VLSI designers are making sure that the performance is good even though the scaling is done. So the previous work, the first reference was the Zimmerman. He took in 2 adder CMOS logics, static CMOS adder and a pass transistor adder, and he worked on it 600 nanometer technology. That was long ago, like in 1997. And the other 2 worked on 180 nanometer technology, and they worked on a couple of more adders, like transmission gate adder, and the other guy he proposed his own circuit, hybrid CMOS, which we're gonna discuss in the later slides. So what is a CMOS? What is a CMOS technology? So CMOS technology is nothing but using a P MOSFET and an N MOSFET in a logic gate. The P MOSFET drives in it charges the output from 0 to VDD, and the NMOS discharges the output from VDD to ground. So the objective is analyzation of each and every CMOS adder and